Hey guys, today we're talking about 3.3 sine cosine graphs, and specifically we're talking about vertical and horizontal shifts. Okay, I'm going to keep this video, I promise, at 10 minutes long. So at 3:50 I will be done. I don't know if y'all can see my time at the bottom right hand corner, but anyways. Alright, go ahead and write down what I have written down as well. Okay, so now yesterday we were talking about amplitude and period, and amplitude stretches or compresses the graph vertically, and our period stretches it or compresses it horizontally. Now we're talking about actually shifting the graph. Okay, so problem number one, consider the parent function y equals sine of theta. Okay, so if we have our parent function and we take a, y equals 5 plus sine of theta, what do you think that 5 does? If you said shifts the graph up 5 units, you are correct. Okay? Just like b, negative 3 plus sine of theta, we're going to take our parent function and we're going to shift it down 3 units. Okay? On c, remember this is on the inside, so we know it's going to affect horizontally. This is a review from Unit 1. Okay, so it's on the inside. Remember, when it's on the inside, you do the opposite of what you think. So you're going to the left 50 degrees, or 50 units. I would take either one. And on D, y equals sine of theta minus, means we're going to the right, 3 pi over 4. Okay? And this is just all a review from Unit 1. The only difference is that we're just using sine as opposed to using like square root function or the cubic function. So it's nothing new. Okay? Now, problem 2, compare and contrast the following graphs. Alright, I am going to use blue for my first function. Okay, we know, or we should know already, that the parent function of y equals sine of theta, you start at the sinusoidal axis, you go up, then you come back down, and then you go back up again. Okay, that negative, let me use a different color, reflects over x-axis. So as opposed to, you're still starting in the same spot, but as opposed to going up, you're then going to go down, up, back down. Those are arrows, by the way. Okay, so all we're doing is we're taking our graph and we're flipping it over. Okay, looking at B, it's the exact same thing. We're going to, our original, or I should say my parent function of cosine. Again, you should know from doing spaghetti trig yesterday and today doing 3.2 that cosine starts at the top, then goes down to the sinusoidal axis, then down, and then back up. Okay, so this is, the blue is in the parent function. And again, this negative means it reflects over x-axis. So if you say you start low and then go up and then come back down, you are correct. And that's all you're doing. Okay? So I want you to make a box, because this next part, or star it or highlight it, but you've seen this before, but I think this will help. Okay, so this is important. So A stands for amplitude. Again, we talked about this from yesterday, so if you don't remember, you know, you want to write down that it stretches or compresses it vertically. Okay, B is the period. Again, this is a review from yesterday. This is the stretch or compression horizontally. So if you don't remember that or you didn't take good notes, you want to write that down there and there. C. So if it's plus C, you move up C units, and if it's minus C, then you go down C units. So that's a vertical shift. And then D, remember it's on the inside of the equation. So if it's plus D, that's a terrible D, but go with me. You go left D units, and if it's minus D, you go right 2 units, or D units. Okay? So I'm going to give you 3 examples, and that's it. And then we're going to have some practice tomorrow. First example, we got y equals 4 plus cosine of theta minus 30 degrees. So what I want you to do, make a graph. Okay? You're always going to do your vertical shift first. And actually I want to put a little bit more space between my graph points. So 1, 2, 3, 4. And I bet y'all at home are like, whoa, what are you drawing? So 1, 2, 3, 4. That's going to be 1. Okay, so 4 is now my sinusoidal axis. So I want you just to draw a little dashed line horizontally at 4. This is our sinusoidal axis, okay? And that minus 30 means we are going to now start basically at 30 degrees. So this is my starting axis basically. Notice my amplitude and period did not change, so my period is still going to be at 360, and then so that's the period. Our critical points, you're going to take 360 divided by 4 is every 90 degrees. Now think about this, you're shifting them over 90 units, so it's not going to be 90 here, it's actually going to be 120. You take 30 plus 90. Okay, 300, 390. So we just made 1 cycle. Okay, for the sake of time, I'm only going to do 1 cycle. However, tomorrow in your assignment, you have to do 2, to where you just keep adding 90 degrees until you get another cycle on there. Okay, now we just did the hard stuff. After that, it's easy peasy. So cosine we know starts at the top. So at 5, 30. Then it's going to come down to the sinusoidal axis. So 120. Oops, I just messed that one up. It's actually 4, 120. And then down to 3, 210. Back up and back up. So we just graphed it. Okay? And that's it. That's all you do. All right, let's look at it one more. We've got y equals -6 plus sine of theta plus pi over 2. Okay? I know y'all love this type because it has pi in there. So you don't need much of the positive at all. Actually, you don't need any. So -1. Okay, so -6 is our new sinusoidal axis. So make your horizontal line -6. Okay. Again, our period does not change, so our period length is at 2 pi, because our b is 1, and you take 2 pi divided by 1. Then you take 2 pi divided by 4 to find your critical point's distance. So there's going to be a critical point every pi over 2. Okay? Now, we are actually shifting it to the left by pi over 2. So it's going to be at negative pi over 2 is our first one. Then we have 1 at 0, then pi over 2, then pi, then 3 pi over 2, and that's it. You can stop. That's one cycle. If you think about it, if one period is 2 pi, but we're shifting it over to the left, pi over 2, 2 pi minus pi over 2 would give us 3 pi over 2. Okay? I'm going to erase this just to have a little bit more room. Okay? Now, this is sine, and sine starts at the sinusoidal axis. My 6 is still in the way. So it starts at the sinusoidal axis. It's going to go up 1. So it's now at 0, negative 5. Then back down to negative 5 pi over 2. Then then pi, comma, negative 7. That's a comma, even though it doesn't look like it. And then 3 pi over 2, negative 6. So we have not changed our amplitude or period. All we've done is just taken our original graph and shifted it either up and down, left or right. And that is it. And we are done for today. See y'all tomorrow.